Okay, thank you everyone for joining our second cadCAD community call. The format will be pretty much the same as Jeff did last time on the first one. And that will be starting with some introductions where we get to say a bit about ourselves, but I'll sort of give an example of that later. The presentation is by Barnaby Monod, who's working on the Ethereum 2 models. He'll give a walkthrough of that. During the presentation, we can ask some sort of clarification questions along the way, but we'll save another Q&A section at the end. So you've got more meatier questions. Let's bring those up at the end after the presentation. And then at the end, we'll have a call for contributions and more general points on joining all the different channels and that. So I'll go through that at the end. So perhaps to begin with the introductions, it's to say sort of your name, what projects you're working on, what models you have worked with, and also what you would like to model. What else? And anything else you might need help with in cadCAD. So I might start just to kick that off, making sure everything's working fine with the audio. And I've lost my main window. There we go. Okay, so on my side, I haven't worked too much with the cadCAD in Angular, I would say, but I've done some of the tutorials earlier. I briefly had a chat with Amin, some co-coding on his early designs of some PID control for some of the dynamics he was working on. So I just briefly looked at that. But more recently been trying to get the cadCAD tutorials up to date with the latest version of cadCAD. So that'll go into the demos repo once that's done. So that's roughly me. Projects-wise, I had a look at the grassroots stuff as well for a bit, but mostly, I would say the cadCAD tutorials is where I'm looking at the moment. I'll pass it on to Angela.
Okay, hi, I'm Angela Kreitenweiss, co-founder of the Token Engineering Community, 2018. And as mentioned earlier, I've co-founded the Token Engineering Academy now in July, where we are offering structured courses and education around token engineering. And the approach is to take the typical token engineering process of, okay, you define your ecosystem, you work on the dynamic and the economic model, you build a digital twin, you run simulations to verify your assumptions, you implement it, you use it or you have your productive system, and then using the data again to be able in the future to steer your system. This is kind of the rough framework, and we've started with the first course at the very beginning of the process, ecosystem value flows, which is on you designing the ecosystem and then end with the stocks and flows of your system. And this is all to bring people into the thinking of, okay, here's your system, how can you break it down, how can you start with simulations and implement or use the engineering process for token economies. And that's also why I'm here. Of course, I'm interested in what's going on in cadCAD, since we want to shape the courses towards using cadCAD and simulations. And looking forward.
Excellent.
Next one. Raul, good morning.
Good morning. I'm just, I was a part of the ecosystem simulation, ecosystem value flow course, and I'm just in the point of trying to simulate or doing the stock and flow, so I'm just chiming in to listen mostly.
Excellent. Did you want to nominate someone to go next?
Ethan Frey.
Ethan Frey, are you there? Okay, we might come back to Ethan Frey. Who else we got? Bitcoin Warrior, are you there? Did you want to give an introduction? He's actually in the office. We'll see if he's actually at his computer. Yep.
Oh, hi everyone. My name is actually James, just like the other James. At the moment, I'm building an open source wallet, Alpha Wallet. I've been in the space for quite a while, since late 2013, and I'm passionate about all things crypto.
Awesome. Did you want to pick who goes next?
The pink dog with the pink show, yeah.
Are you
The
there,
pink
Dog?
screen.
On my side, that's not showing. Is everyone getting Dog's audio?
Yeah, he's there.
Oh,
David, can you talk?
Are you
Ah,
talking to me, about me?
you
there we
should
go.
introduce yourself.
I would like, sorry, so Discord has been disappearing and I have had technical issues that I've never had before, which I'm surprised at. Well, yeah, I'm David. So I've been kind of lurking around the perimeter of the token engineering community for, I guess, almost 2 years now. And I've participated in the Token Engineering Academy that Angela introduced. And very awesomely, by the way. My interest mainly is in learning more about cadCAD and why I seek to understand through simulations what we're actually doing in the entire kind of decentralized economic space, because I think it's a different way to look at what economies and economics are, and it's kind of my approach to learn it from a non-classical kind of point of view. And what I'm working on at the moment is trying to create a small, concise economic understanding of the carbon, of a connection of the actual climate carbon cycle and a small system that actually interfaces with that, but is based on economic principles. So you actually have ins and outs between what's happening with carbon in the climate, and connect that to an actual economy where you have people providing certain services in exchange for certain values. And I'm just trying to wrap my head around what is necessary to make that happen, and then start with small simulations at some point to just show that it can be done and what the tools will be that we will be using for that.
excellent. So who's up next? David, did you want to suggest someone?
I was in and out of the call, so I don't know who was on yet. What about Tyler? Has Tyler introduced himself?
Yep. Tyler?
Can you guys hear me?
Yes.
Yep.
I am from the States, very late, but I thought I would just join and sort of piggyback on the conversation a little bit as I lay down. But just recently joined Block.Science not too long ago. It's been a couple of months working on cadCAD. So yeah, that's my interest. Seeing what everyone.
Great. I'm just going to see if Ethan Frey's back. Ethan Frey, you there? Okay. We might jump to Dominic.
Hey guys, my name is Dominic. I kind of do two things. I'm a PhD student at Impero, where I work on kind of collateral optimization and reputation systems and cryptoeconomic systems. And then in my the second thing that I do is I'm a co-founder of a company called Interlay, where we build cross-chain solutions. And currently we are working on a Bitcoin to Polkadot bridge in pretty close collaboration with the Web3 Foundation. And I basically I want to use cadCAD for modeling some of the fee models that we want to develop for the specific bridge. So we have like a proof of concept, but like the fee model is still a little bit in flux. And I thought it might be a great idea to actually have some proper simulation and testing before releasing anything into the wild, where we might have some unexpected behavior. Yeah, that's me. I think I'm the last one, right? Nobody else to nominate.
Yeah, I think if Ethan Frey isn't there, then I believe that's everyone. Okay, no Ethan Frey. Just make sure I'm still recording well. Excellent. So then, yeah, I should say, main introduction probably will go to our speaker. So yeah, let's just get straight into it. So Barnaby, would you like to introduce yourself and then, yeah, start with your presentation on ETH2?
Sure. Thanks, James. I just want to say first that it's really nice to have the talk on Asian compatible time zones. I have another one later at 11 p.m. and it's always a bit, it's quite late. So yeah, thanks. But really happy to be here. Let me find out how to share my screen. Can you all see it?
Yeah.
Yep. Okay, awesome. So I'm going to talk a bit about my work on the cadCAD simulations with ETH2. I've been working on this since about January when I joined the Ethereum Foundation. I'm part of this robust incentives group. So our goal is to look into incentive design, protocol security from a more economic, let's say, point of view. And so the work I've done with cadCAD was an attempt to embody the economic principles of ETH2 into like a nice simulation environment that allows us to test. And so today I'll walk you through a couple of designs that I went through and give some insights into how cadCAD made it work for me. I actually had a slide on my journey, but since I've been talking about this, that's fine. I'm currently focusing on ETH2, but also I'm looking at the EIP 1559, which is a reform of the fee market for Ethereum. And I'm also going to be looking into auctions, so designing on-chain auctions. Yeah. Also another thing is feel free to interrupt me at any time if anything is unclear. I think I don't have so many slides, so the presentation is not going to be too long. Just let me know if you have a question. All right, so I'm not going to assume that you know anything about ETH2, so I'll just give like a very brief recap about the design, how it's supposed to work, and then I'll walk you through the few designs that I had for what I call the Beacon Runner, which is the simulation environment I developed with cadCAD. Okay, so let's dive in. ETH2 is the planned Ethereum upgrade towards introducing proof of stake and sharding. It's a multi-stage endeavor. It's pretty complex. It's going to be released in a few phases. The first phase is phase 0, and that introduces the Beacon chain. I'm going to explain what it is a bit after. And in phase 1, we'll introduce the Beacon chain and additionally shards. But the shards won't really do anything at this point. They'll just be introduced for the sake of being introduced. And it's in phase 2 that you really start to see ETH2 as the full system that it's meant to be, where the shards are actually doing something and talking with each other. And the Beacon chain is kind of sitting there in the middle, trying to organize the system and make sure that everything is running well. So all of this is kind of coded or specified in what we call the ETH2 specs, which is really the definitive guide to client implementation. So it tells you how the chain should run. One image that I have, if you've seen this anime, is that the ETH2 specs are kind of this big robot, like this very complex machine, but it doesn't really have a soul. Like it doesn't really move or anything until you start feeding it with client policies. So when you actually start saying, well, what should you do with that? So the specifications are just this inert thing. And so where my simulations fit in, they're kind of in between the ETH2 specs, which is more of the, let's say, sacred text. So that's the truth. We look at it as the truth. And on the other side, you have the validator clients, which are actually the ones that we are going to use to run the mainnet. So the things that will interoperate between each other, have each client run a copy of the Beacon chain, and also implement the validator policies. And so the beacon runner that I developed using cadCAD kind of sits in between the two. It's not as fully fledged as a client, but it's also not as inert as the specs. Okay.
Can I ask a quick question about the specification? They're sort of developed like as a more of a long tail thing. They're developed sort of well in advance. And is that what's sort of the language or the syntax used for that?
Yeah, so the specs are written in Python. So it's a mix of Python and just written Markdown. But what I've done with the beacon runner and that I'm going to show a bit is I actually took the Python parts of the spec. So you can run the specs, they're well-written Python with tests and everything. What I've done with the specs is take these Python pieces and just wrap them into this cadCAD simulation framework. All right, so the specs are actually code that you can run, but just doesn't really know what to do yet.
Excellent, thank you.
Does that answer it? Yeah. Yeah, so you can really see Eve2 as a controlled dynamical system, which is really what cadCAD is meant to be working for. So the specs, they define valid state transitions. So we move from one beacon state, which is a state of the beacon chain, to another one. So state transition, for instance, is adding a block to the chain, or processing deposits of incoming validators, or processing the rewards, because validators are rewarded or penalized depending on their behavior. On the other hand, the validator clients, they're the ones who control this state transition. So they're the ones who propose a block, they're the ones who propose an attestation, and they'll do more and more things as we move to later phases and as Eve2 is more and more developed. So to give you a kind of mental picture of what it looks like, at least in phase 2, it's quite simple. We have a chain of blocks, which is the beacon chain. So I represent them in blue here. And each block contains a set of attestations pictured in purple. And the attestation simply reference previous blocks. And they say, I've seen this block, and I attest that this should be part of the canonical chain. So very simple, just blocks containing attestations. Okay. So my first beacon runner, so the first simulation environment that I created, I call it centralized because I took the parts of the specs which were defining the state transition, and then I coded one logical agent, which represents basically all the validators which are interacting with the chain, and they all update the same beacon state. So I'm really modeling the ideal case here. I imagine that all of these validators, which I represent, are honest. So they correctly include new blocks, they correctly include attestations, like they're not trying to be malicious or to deviate from the protocol. And there's also no latency. So they all have the same view of the chain, which is this unique beacon state. And they all play by the rules as they are spelled out in the specs. And so the simulation steps are quite simple. When we are at the head of the chain, right after the latest block, the first policy that we have, so policy is a cadCAD word. So the first real interaction, real control that we have is that validators are going to attest to the latest block and say, I believe this latest block should be part of the chain. And the second policy is that someone is going to propose a new block. So to continue the chain of this block, including the attestations that were proposed in the first policy. So this takes us to a new head, and we repeat. All right, so I've littered the presentation with a few links. I will just walk you through quite quickly. So these are all in notebooks where I try to give also a bit more educational overview of how Eve2 is working and how I actually include the specs into this cadCAD environment. But you can see, so cadCAD is very nice because it's fairly, how would you say? You can read it as if it was English pretty much. So if I show you here, this is exactly what I've been telling. We first start by updating. So we move the slot by one. Someone is going to attest. we update the attestations that we know about, and then someone is going to propose a block. That's a policy. And then we update the state with this block. So really classic cadCAD kind of behavior. You pile up policies with state transitions where your state is changing. What I was hoping to get out of this is simply to see that when validators are correctly following the protocol and doing what we expect them to do, their rewards are increasing over time. So this is the line that I plot here. All right. So this was the first attempt. It's block by block transitions. Since every validator has the same view of a chain, and I only assume that there's this one canonical state that everybody agrees on, it's fine for the simulation to simulate block by block. So each step of the simulation is just one block. But this is something I change later on. So of course, we're never in the ideal case. So in my second beacon runner, I was trying to understand like what happens when the network is splitting. So network splitting is one of these bad events that we, if not prevent, we at least want to manage carefully when it happens. So imagine here that we have two sets of validators which cannot communicate with each other. So already we start to introduce the fact that the validators are peering with each other. So they exchange information. I've seen this block here. You should see that too. But now we have two sets which are disconnected, and each set has their own view of a chain. In this case, it's pretty bad. Neither of the chain is doing what we call finalizing. There's not enough weight in either of the chain to say, well, this is the canonical version. And so what is happening here is that validators in proof of stake give you some deposit. The deposit is there for them to receive an interest or a reward when they are doing things correctly. But if they are not, the deposit starts being emptied by the protocol. So in the case of these network splits, if both networks are unable to finalize, the validators are going to start losing Ether. The deposit is what we call leaking. And it leaks until the inactive validators, so yeah, the inactive validators are small enough that their weight is small. So this second proof of concept kind of introduces a new object, which is the network. So in the first centralized beacon runner, I did not really look at what happens at the network level, but here already I'm looking at it, but in a very still centralized way, since I assume that both sides of the partition, they each have their beacon state, and they all agree on the state of their own beacon chain. All right. So this is here. So what I show here is that indeed on each side of the partition, some of the validators are inactive, and the inactive validators are slowly losing money here. And after a while, when enough validators are losing money, the activity ratio, which is what we use to say, okay, the chain is finalizing again, is jumping above 2, which is what we want. You can find more details in the notebook. All right, so this is good, but it's still sort of centralized. It's still not really what is happening in reality, because in reality, each validator really has their own view of the chain. So they're part of this big peer-to-peer network. They receive messages, they receive the new blocks, they receive the new attestations, but they don't all have the same view of the chain at the same time. So what we really want to do here is create what I call the agent-based model runner, where each validator has its own, let's say, brain. Each validator has its own way of managing the messages that it knows about, the blocks and attestations. And each validator is able to take decisions independently of each other. In other words, this is kind of an asynchronous behavior in the sense that you don't have a single clock running for all the validators. Validators now are able to independently perform actions, send messages, attest, propose, etc. So how I do this is I...
Sorry to interrupt. Could I ask one question at this point? Was the this simulation done prior to implementations being written? Was this sort of in the design of the specification, simulations were done, and then that enhanced the spec?
Yeah, the specs actually were already written. They've been written for some time. They've been evolving over time, but I would say this part of the spec was fairly cemented by the point the simulations were done. Yeah.
Okay, thank you.
So I've been using, the specs have been frozen about like a few months ago, and this is where this third beacon runner kind of started. So yeah, not much change
Okay,
from the spec
so,
side.
so it's more so to enhance the implementation for validators, to give them some insights into problems that can arise.
Right. So we'd like actually to understand if the behavior that is given by the specs for the validators is actually rational behavior. So is that behavior rational for the validators to follow? And so the idea here is to be able to design simply different types of validators and have them compete with each other in the simulation environment and see, well, this behavior that we call honest in the specs, is that actually the behavior that gives you the highest rewards? So the point of a beacon runner is to arrive at this this thing where it's very simple to specify different validator behaviors and to have them compete with each other and see the reward that they have.
Great.
In particular, I give a simple API. You only need to define these two functions. So a validator can attest given its current information and propose given the current information that it knows. And what happens now, instead of having the simulation run block by block, I kind of split the time, discretize it in very small time steps. Each second or tenth of a second or thousandth of a second, I ping every validator and say, well, now do you want to attest? Now do you want to propose? And so when I ping them, what I do is I actually call their API and they tell me, okay, I would like to propose a block. I would like to attest now. And so by defining these, implementing these functions, you can define very different behaviors and see, well, which is the behavior that is doing the best in different network conditions. I will show this notebook. This is the latest one that I released. You can find it on Twitter as well. So here I picked two different validators together. One that I call the ASAP validator because it wants to attest as soon as possible. So it's kind of an honest validator. And a different validator, which is more prudent, which waits a bit to see that to make sure that it attests correctly. It's a very simple difference between the two. It's a small nuance, but it actually makes a difference, as I see, by pitting them both. So putting both validators on the same network, mixing the different validators on the network between ASAPs and between prudence, I can see that over time, one of the behaviors is actually getting better payoffs than the other one. And so I'm able to say that, well, if I was rational in these bad network circumstances, I might prefer to implement the prudent behavior rather than the ASAP behavior. And so the point of a beacon runner is to be able to specify very simply these different behaviors and have them compete with each other. So when I say simply, this is, for instance, the specification for the prudent behavior. So if it's not yet the moment to attest, I don't attest yet. If it's too early in the block, I'm not going to attest. And eventually, if I find that, okay, the conditions are there, satisfied for me to attest, I will send my attestation. Is that clear? All right. And so I find here in cadCAD, so it's able to, I haven't used it here, but I'm planning to integrate that to do a parameter sweep. So in my simulations, you are able to kind of make the network latency go up and down. So you can have a very bad network where the messages are propagating very randomly, or a network where the latency is almost perfect. And so when I change the update rate here to have a network with better latency, I now find that there's not really a difference between the two different behaviors that I implemented. And so I can see that maybe the prudent behavior is more robust to bad network than the ASAP behavior. Yeah. All right, so I think this is a pattern which is fairly general in cadCAD. So having this agent-based model and having validators or events that happen sort of asynchronously with respect to one another. In this case, I find that this time discretization, it works quite well. and having simple APIs to define the agents of your simulations. Yeah, this is a pattern that I'm planning to reuse for the EIP 1559 research that I'm doing. Okay, this is a bit more cadCAD specific. As you can imagine, the state space is quite large. I think most cadCAD models I've seen deal more with flows. So you record, let's say, the amount of money in the system at different parts or different time. But here my state space is quite large. There's this network of validator. Each validator is maintaining their own state. So of course, I'm doing a bit of caching behind the scenes because at some point in time, a lot of the validators have the same view of the chain, but it's still very large. And once you start discretizing time in very granular intervals, you have many, many different iterations. For instance, if I discretize down to every millisecond, I'm going to end up with many, many copies of the state space. And by default, cadCAD deep copies the state from one step to the next. And so that at the end of a simulation, you can sort of go back through these historical states for later retrieval. But this is quite slow. When you deep copy something in Python, it takes time and it slows down the simulation quite a bit. So the typical pattern is to record the state at each simulation step. And at the end of the simulation, you map each of the state that you recorded to simpler metrics. And the metrics are usually much, much smaller than the state is. So for instance, in my simulations, the state might be this set of validators and the view of the chain that they have. But what I'm actually interested about is simply the pair that they have at the end of the simulations. So when the dynamics are Markovian, which I mean they don't really depend on past states, and the state between state 3 and state 4, I don't need to know about state 3. I don't need to know about state 2, state 1, or state 0. So when I don't have this dependent on the past, I can just forget the past states as my simulation goes along. And so I developed a small library to add to cadCAD, also based on a fork created by Dan, where the link is here. This allows me to use cadCAD by making shallow copies of the state at each iteration. And instead of doing the simulation and then mapping the metrics at each timestamp, I map the metrics every time I do another step. So instead of recording all the states and then going through all of them to map the metrics, I do the metrics one at a time. You can see more info here. I think this is a post to the cadCAD community forum. This is a bit more cadCAD specific, I guess. My further plans are to keep integrating more of the specs into the runner. So I've only mentioned the blocks and the attestations, but there's actually quite a few more things that validators can do, such as slashing proposal or aggregating the attestations. This is more if2 specific. I also know of faster specs which were written by another EF researcher. This should improve the speed because actually it's quite slow at the moment. I'm trying to work out a few pickling bugs preventing cadCAD native parallelization. So I think pickling happens when you're trying to parallelize, for instance, different simulations running in parallel if you're doing Monte Carlo or stochastic simulations. And right now the beacon state is not pickling correctly. And so this prevents the parallel simulations to go through at the same time. And of course, the most exciting thing I think is to test different behaviors. So try and work out what else could a validator do? What are the policies or the behavior that it could implement? And still try and test and see if the validator, the honest validator given by the specs is indeed the most rational behavior to follow. Yeah, and that's about it. I hope it was clear, and let me know if you have any questions.
Excellent. Thank you very much for that. Yeah, so let's open it up to Q&A if people want to prepare any questions or have any questions.
I have a question. It feels like you have been able to really take the specs as they are and use them in cadCAD. I somehow always felt like you need more translation. So this seems to be the perfect case or perfect process. Or what do you think about it?
Yeah, I think it's quite true actually. So the specs are really the ground truth. So the more translation you're doing between the specs and between the actual system that you are modeling, the more you lose. Like maybe you have, I don't know. There's been like a few bugs around integer overflow, for instance. So places where if you move from one language to the next, you might not have the same behavior. So having most of the code coming from the specs and using that as a reference and then wrapping cadCAD around it, I think it makes a lot of sense, in fact, and it avoids these issues where, you're losing something in the translation between your system and between the simulation of your system. Yeah.
But it's quite an ideal case, isn't it? So maybe, James, I don't know if this is a regular, but we at least.
I guess it is, yeah.
Yeah, I think
so it's an ideal case. Yeah. No, I think James was asking where the specs written before the simulations were, and yeah, it's also ideal in this sense, which I think the simulations really come earlier. So at least in the design stage, you're trying to iterate quickly on many different things. And I guess I got kind of lucky that I already had this ground truth. I'm hoping that now that I've caught up with phase 0, I can start moving towards phase 1 and phase 2 faster than the specs are already coalesced around, let's say, the truth. And then the simulations might be helpful to also explore the design space, let's say.
Yeah, this would have been my second question. So it's, on the other hand, you say, okay, specs are the ground truth. Feels also they are finalized. How do you plan to, or is there this iteration cycle on, okay, these are the results of simulations. How can we optimize the specs now? So how is your collaboration between specs people? Are you part of the specification team, or how does it work?
Yeah, I'm in contact with the Eve2 research team, so I definitely know where they're going, and they give me feedback also on the simulations. This last notebook that I showed, where you have different behaviors, and one of them is overtaking the honest behavior in cases of bad network latency. I think this is an issue that might need like further inspection, and that could lead to changes in the spec later down the road. But right now, it seems like a fairly minor issue given the, let's say, the scale of everything else. So I think the position is more to keep the specs as they are so that we are sure there's no bugs and launch then on mainnet, and perhaps iterate and make improvements on this later down the road. Yeah.
Cool.
Excellent. So did anyone else have any questions? We've still got, obviously got some time.
I was wondering about your choices of how the quality of the underlying network is. So, I mean, I think that's the slide we're looking at right now. You only set a kind of global setting for the quality of data transmission that you kind of estimated. Are you planning to see how if there is any kind of unexpected behavior when you have different clusters of validators having different network conditions? Are you planning to look at that?
Yeah, that's a good question. The network currently is quite simple. I think I really wanted like the minimal viable network where I could have these latency issues, and I was hoping that through many different simulations, like randomizing the topology, randomizing the positions, I might explore, let's say, a larger space. But it could also be possible like to simply extend the network object that I use and to have like these differential latencies on different parts. But you could also imagine that these clusters, if you are, let's say, randomizing the topology, you might have networks with higher diameters, or you might like organically reproduce these kind of things. But it's definitely possible like to have, yeah, it's not there in the code currently, but it's something that wouldn't be like too difficult to add.
Yeah, no, I think that's a really good question. Anyone else with any other questions? I'm just trying to think. Yeah, I found it quite interesting back the slides you had with the different time steps you were experimenting with, and how obviously with cadCAD, it would be generating the state for each step and passing that on. So it's a nice optimization to hear that you're just looking at the results. I was wondering if there's a way that if a lot of the time most of the agents are actually not acting in a time step, would that be also another time step? Like, is a state created per step even if no actors have actually acted?
Yeah, currently how it is, it's yes. I think you could move to a representation where the step that cadCAD is using is not like a fixed duration kind of step, like not every millisecond, but let's say from one event to the next. But I found that it felt a bit like more complicated to represent and even to reason about. So I find this representation a bit simpler to handle, because the moment you start introducing, okay, the simulation step depends on what the agents are doing, that it becomes quite circular. Like you're waiting for somebody to do something, but also, yeah. I didn't find like a good mental model to represent it, and I thought it also didn't really fit the cadCAD, let's say, philosophy of having like these state updates and these policies.
Yeah.
But I guess it should be possible as well.
I guess I can't help but think of sort of games and simulations of that nature. Like if it's a real-time game, you do want every time step no matter what, but in others, where you're just replaying the state back, you don't mind just getting the event, like the changes as a type of compression.
Yeah.
But
Yeah, at the end of the day, the tape is quite simple because you don't have like too many actions. But to get to this like tape, I think you still need the discretization. Yeah.
Great. Before we jump to the next section, we'll just do a final call for questions before we wrap up. Just give it a moment. Okay. Make sure I'm still recording well. Excellent. So then, yeah, we might just jump to the next section. Like a lot of the resources that were shared, we'll put them either in the Discord chat or, I think the Discord chat might be the best place, but let's go through the links here. I'm just going to read off Jeff's notes here. There's basically a call for contributions in the cadCAD. We're back in. There we go. So basically it's a call for contributions in the cadCAD community. That it's an emerging community of makers who see the importance of open source modeling and simulation in complex systems design. It's a mouthful, so I had to read that. We welcome ideas and contributions in all forms. There's a few places to get involved, and we'll share them all in the Discord because that's where we are now. So just above the video chat where we are, above that there's the Discord channel. There's also community.cadcad.org for more of the forum things. And then there's the working groups also in Discord. There's the core tech, which is upgrades to the cadCAD core. There's admin infrastructure, keeping integrations running smoothly, and education and outreach, which is explaining models and growing the community. So forgive me for not memorizing all that. Have I missed anything? Just any others who are aware of that? Just making sure I got everything there. Okay, and then given we've got some more time, if there's feel free to jump in with any questions or any comments generally in the cadCAD space. Does anyone want to share something they're working on, something you're interested in? But otherwise, we'll get these resources out there in these channels. The last call. Please.
Since I realized that Dominic is here, it's Dominic Hartz, isn't it?
Yes.
Yeah,
yes,
cool.
That's me.
I mean, we have been in touch, but we've never talked to each other in person. So
Yes.
I think, hi again. You have been working, I remember the paper, for example, you've published with Ben Lifshitz on, I think you modeled a crypto market and a market crash. So I would love to hear more on what tools and framework you have been using there.
Right. So that was our decentralized finance crisis paper.
Yeah, basically.
So basically, we wrote all of the code from scratch, and it was mostly Lewis, who's also at Imperial, who wrote that. It's basically a Python model. We didn't really know about cadCAD when we did the paper, and Lewis basically used just like basic standard Python packages to do like the Monte Carlo simulations on some Brownian motions, and we basically use that, I guess.
And I think you also model different agents, right?
Well, we didn't model too deeply about like behavior of different agents, but looked at more of the overall collateralization of DeFi systems. So a bit more of a macro view, rather on. I mean, you could extend it. I think that's where cadCAD would be interesting, is to include some kind of different agent typings and different strategies that agents would take. Which we didn't really model. So we were basically saying, okay, the overall collateralization ratio of all of DeFi or in lending protocols falls below a certain level, but kind of glossing over the different strategies that agent could take, and if like say more reactive agents or more agents that say have more capital at hand that they can use to kind of keep their loans afloat or deleverage, make a difference across different agents. But that would certainly be a kind of a nice extension to that.
Yeah, that's definitely one of the things I like about cadCAD, that is that you can have sort of the traditional, I guess, I'm not sure what you call it, formulaic modeling or just sort of equation-based modeling, and then having the sort of more AI-like or behavior-based agent or agent-based modeling. Yeah, I found that always really interesting about it. So it's good to see it being applied, for ETH2, and yeah, it's definitely inspirational just to get back into it, just to see real applications that have a use case. Like either in your scenario you had it maybe after there were solid specs, and it can help maybe inform validators a little bit on some behaviors that arise. But then maybe for other phases where the specs are more loose, it can feed back. Not only feed back to looser specs, but then feed forward after that to implementations. It's just the utility of it. I'm already feeling and tasting. I find that really exciting. So were there any other questions, comments?
I have actually one question. I think one interesting aspect of if kind of everyone or major parts of the community would use cadCAD, would there be some sort of way to kind of combine models to create ever more complex things? So when I think about if we have some MVP working model of ETH 2.0, and if you would want to model, say, Uniswap and then another DeFi protocol on top of that, I was wondering if it might be possible at some point to compose these models together to kind of figure out how the behavior of the agents would be. But I guess the ultimate limitation might be state explosion and computation power, because the models become so incredibly complex. But I don't know if anyone is working on that or has some specific thoughts on that.
I think it's a great idea. Is anyone, I'm not sure if in the token engineering community there was talk of a library of shared resources, shared modules?
Yeah, maybe I can talk about that. Okay, a library of shared models would be, of course, then super exciting. I think the first step we are currently working on is having a library of value creation patterns as a combination of certain mechanisms, its context, the use cases, the application case, the network's purpose, and then modeling results and cadCAD models, ideally, as long as we have that. And I think we won't have it in many cases, but just to show how being able to compare and model these elements and building blocks of cryptoeconomic systems can help to make better choices. And of course, I would love to have in the future reusable components for modeling. And I think the entire question of composability is exactly waiting for that. How can we deal with that, since it's happening at the moment right now today, and we have no clue. And I don't know if you observed what's going on governance, and how, for example, Gauntlet is trying to educate or make progress in the field of risk management and information on governance decisions, because most of the proposals on changes in the protocol, for example, what collateral are included, then it's mostly the analysis of, okay, is it good or bad? What are the risks? Is tied to code itself and not tied to systems. And then interconnectivity of systems. And I think, and they try to make this more visible and try to provide analyses on, okay, this proposal might have these results. And I think this is the direction also our community has to take to make it more transparent. And definitely, I totally agree, Dominic. This is the way to go.
Yeah.
But certainly, challenges along the way we have to solve.
Yeah, I often, like, I think one of the examples I played with, or at least when I was trying to write my own cadCAD early on, was to just think of the types of actors in a financial system. Is there the hodler, the greedy actor, and maybe for those regular users or types of people holding crypto, that would be an interesting shared library, an interesting set of behaviors to develop, and to say, what does a hodler do, and just play with those tweaks and parameters for them versus a greedy, maybe a regular investor who's arbitraging, but maybe a greedy investor who attempts to shift the market and use flash loans to do things. Or yeah, I'm not going to talk about yield farming, but it'll be just interesting to see these behaviors emerge in our models prior to the market. That would be a great place to be.
Yeah.
So.
And at the same time, I feel like this automation of agents and kind of designing your bots to make the most out of it for you. Maybe it might be a race. Not sure to what extent. For example, validators. We are assuming two types, and there might be weird behavior that is really not let's say not driven by human decisions, but you explore the system, you try to find the gaps that you can make use of, and then create bots. And maybe the development of those bots might be always faster than our like making sense of behavior of agents. But I think, yeah, this is kind of this is a race
Yeah.
I see. Not sure what you think about it.
Yeah. Any comments on that, Dominic?
Yeah, I guess ultimately the goal would be, if you had something like in the cryptography community of UC, like universal composability, if we have something along those lines. But then I also think a lot about not just agent types, but for example, what if you want to model specific attack scenarios? So reordering of blocks, bribing of miners, and like this whole space of complicated behavior, maybe one by one, and to see how the protocols behave. But yeah, I think it's definitely the right direction to go. And I would love to have that library of different models and different incentives and different users. I think it would be cool to just collaborate on that.
There's a working group. Happy to share the link for this library in the engineering community.
Awesome.
Cool. Yeah.
Great. I think we're getting close to the end of the hour, so right on time. I'll just conclude with, if you want to support the cadCAD education and development, there'll be the place to donate to the Gitcoin grants, and also donating fiat to their open collective. So we'll share those links in the corresponding channels, and Discord, Telegram, and community.cadcad.org. But yeah, in terms of these optimizations, I like to just maybe to conclude with a bit of a story from high school. When I was first learning kind of using Excel's optimize function, where the computer would optimize something for you, we were trying to feed a space colony, and all the different foods would have different types of advantages, like having maybe protein or vitamins and whatnot. And when we did it ourselves, we were always trying to get the maximum growth of the community by playing with these different parameters, and then seeing what the over time what that would do for the community. When you went to optimize, it just went straight to Brussels sprouts. it would just feed everyone 100% Brussels sprouts because it was the most effective thing. So, and as humans, we never saw that. We never saw this sort of edge case, if you will, of what a computer would say, this is the optimal path. So maybe it will be a blend, not just us modeling our own agents to do behaviors we think will emerge, but actually letting the bots evolve within the simulation first, and then maybe we can beat the bots that are out in the wild. So we'll have to just play with that, and it'll be a race of the bots in the end. But yeah, let's keep building these cadCAD tools, let's keep building these models, and thank you very much for joining me at this wonderful time zone.
Cool, thanks.
Cool.
Thanks,
All right, thanks everyone. Yep.
Bye.
Thank you very much.
Bye.
Thank you. Bye.